Hey everybody, Miss Callahan here. I hope you are having a fantastic day today. We are going to jump right into lesson 2 of Unit 2 called Physical and Chemical Changes. Let's take a look at this week in science. On Tuesday, you did sort of an introduction to our entire semester B in science and had a quick check. On Wednesday, you guys had an introduction to our first unit, which is all about changes in matter. And then today, we are going to talk about physical and chemical changes and have a quick check with that one. And finally, on Friday, you'll learn a little bit about conserving mass and have a quick check for that assignment. Okay? So let's go. The two types of changes that we're going to learn about in this unit are physical changes and chemical changes. We're going to talk about what the differences are between them, how we can identify them, and look at some different examples of each one. So, first up, physical changes. A physical change is a change that changes the form or state of a material, but not its chemical makeup. So when we make this change, there are no new molecules or particles or substances that are formed. So whatever substances or materials we start with, those are the ones we're going to have in the end after the change occurs. Nothing new will be produced. Another thing to note about physical changes is they can be reversed. Now, they're not always easy to reverse. Sometimes it can be kind of tricky to reverse them, but it is possible. For example, one physical change would be cutting paper. Now, can I just stick those papers back together and everything is good? No, we're going to have to glue them or tape them or find some way to put them back together to undo that change, but it can be undone. It can be reversed. Some different evidence that we can look for to determine if something is a physical change is first, change in size. Think about that piece of paper. It was one big piece of paper, but I cut it into two smaller. Still paper, just smaller. Another example would be a change in shape. Let's say that I take some Play-Doh and I form it into a ball. And then I take the Play-Doh and I smush it and make it flat. The shape has changed, but it's still Play-Doh, still the same material. A change in color. Now we have to be super careful with this one because change in color could also mean it's a physical change. We have to think about it in a couple different ways. Let me give you an example. If I had the piece of paper we were talking about earlier and I colored it, my favorite color, green, it's still paper, right? The paper has not changed into something new, but it looks different. Now it is green. It's had a color change. And then finally, change in state. If we take, let's say, water and apply heat to it to make it boil and bubble, it's going to evaporate and turn into a gas, right? But it's still water. It may have gone from a liquid to a gas, but it's still water. If I take that same water and I freeze it into ice, it becomes a solid, but it's still water, just in solid form. So a change in state is a physical change. Let's look at some other examples of physical changes. We have ripping paper, melting butter, breaking a pencil, and bending a paperclip. None of those things change. In the end, we'll still have paper, butter, a pencil, and a paperclip, but they've just changed their size, their form, their shape, those kind of things. All right, let's talk about chemical changes now. This is the other type of change we're going to be studying. A chemical change is a process that changes the chemical makeup of a substance. So there will be new molecules and new particles. New things will be formed. In the end, you will not have the materials you started with anymore. You will have something new and different. The thing about chemical changes is they are very difficult and most oftentimes impossible to be reversed. Look at some of the examples below. Think about baking a cake. I'm going to throw in all my ingredients, maybe some sugar, maybe some eggs, maybe some milk. I want it to be a chocolate cake, so I'm going to put some chocolate in there, and I mix it all up. I stick it in the oven, and I bake my cake. In the end, I have something new. I don't have these individual materials or substances anymore. Now I have cake. Something new was formed. Can I take that cake and separate back out the chocolate and the milk and the eggs and the sugar? No, there's no way to undo it. It's impossible to reverse the change that took place. So let's look at some evidence for chemical changes. Whenever light, heat, or gas is released, that is evidence that it was a chemical change. We'll look at some examples of those in a moment. Whenever the temperature changes, for example, the change in my cake, first I had all of these ingredients that were maybe cold or room temperature, but when I had my cake, it was nice and hot and fresh. There's a temperature change there. If there's a color change, remember I told you that could be a physical change or that could be a chemical change. We'll talk about some examples of color change in chemical changes in just a moment. And then finally, a new smell. Now, not always is a new smell going to be formed, but think about when I baked that cake. When it was in that oven, I probably was starting to get the yummy, delicious fragrance of the cake as it was being baked. There was a new smell that was created. And then finally, formation of bubbles. Watch, this is when you think of pouring in a bunch of ingredients and it exploding into a big explosion, or bubbling over, or erupting like a fun science experiment that you have to wear goggles for. The formation of bubbles is a clue to us that it was a chemical change. So look at the examples again. We have lighting a match. When we light a match, both heat and light are produced, right? That red tip that was on my match is now going to be black. That's a color change. Baking a cake, frying an egg, or toasting a marshmallow. Think about toasting a marshmallow. It was white and maybe cold or room temperature. Now it's hot and it may be light brown or dark brown or crispy black, depending on how you like your marshmallow. So let's play a little bit of a game. Let's see how well you were listening and paying attention. I'm going to give you some changes and you tell me if they are physical changes or chemical changes. Ready? The first one is lighting a match. Now, I just told you the answer to this one on the last slide, so hopefully this is a freebie for you. Which one is this, physical or chemical? All right, let's see. I hope you said chemical. Yes, it is a chemical change. Like we said, there is light being produced or released. There is heat being released. The temperature changes, right? It goes from just a normal match that we can touch to a very hot item that you do not want to touch anymore. What about cooking food? Cooking this meat right here. Is this a physical change or a chemical change? What do you think? Okay. Let's see. It was a chemical change. Once we cook this meat, can we undo that? Can we reverse it back to uncooked meat? No, this is a change that is very difficult, pretty much impossible to undo. We cannot make it go back to uncooked meat. The color changes. You see the bubbles forming as the grease cooks and it gets hot and makes a new substance. It goes from raw meat we cannot eat to delicious cooked yummy meat that we can eat, that is safe for us. All right, what about dissolving sugar? Physical change or chemical change? What do you think? Good job, you're getting good at this. This is a physical change. It's a physical change because we are just taking the sugar, mixing it with the tea. We still have sugar and tea, no new substances formed. Also, we could evaporate out the tea by applying more heat and the sugar would be left behind by itself. We could undo this change. We could separate out the substances that we started with. Ooh, hand warmers. Has anybody ever used these before? These are like one of my best friends during winter time. So hand warmers are basically you take them out of the package, you shake them up, and they get nice and warm. And you can hold them in your hands, and put them in your gloves, put them in your shoes. It keeps you nice and warm when you have to be outside or somewhere cold during the winter. So, what do we think? Chemical change or physical change? All right. Yep. It is a chemical change. Heat is being released. Once we shake it and that change takes place, heat is being released, which is what warms it up and makes it nice and warm for us. Another thing to think about is we can't undo it. once we shake it and that heat is formed, we cannot put it back in the bag and pretend like we never used it. It is different. It has changed. It cannot go back to how it was before for us to use again and again. It can only happen once, so it cannot be reversed. All right, y'all, one more. Rotting eggs. What do you think? Chemical change or physical change? Let me hear ya. Chemical change. It's a chemical change because we go from a perfectly good egg that's fresh that we can eat, like or cook and eat, to a rotten egg that I don't think we're going to want to eat. A new smell is definitely produced, and it cannot go back to a fresh egg. We cannot undo this change or reverse it. So it is a chemical change. All right, everybody, you are ready. I hope you've been taking notes and paying good attention. Now you're ready to go through your lesson and rock that quick check. High five, everybody. I will see you next time. Bye.